Hello and welcome to everyone joining us today. My name is Amber Cobb and I lead OnLogic's technology ecosystem. As a reminder, today's webinar will be recorded. Please use the Q&A feature located at the bottom of your screen for any questions you have. We'll be using the polling feature and encourage everyone to participate. I'm confident you'll find something valuable in today's talk. Thank you for your time. Now let's get started. Allow me to introduce my guest who will be helping all of us learn why edge AI pilots get stuck and how to move them into production. Please welcome Sachin, VP of Product and AI at ZEDEDA. Hey, Sachin, welcome.
Hey, Amber, I'm glad to be here.
Oh, gosh, so I imagine that some of our audience may not be familiar with OnLogic or ZEDEDA, so I'd like to get started with a brief introduction to our companies. For those of you new to OnLogic, we make computers, but not just any computer. OnLogic makes reliable industrial computers and edge devices that are highly configurable to meet the demands of the most challenging environments. Part of what makes OnLogic computers special, beyond that bright orange color, is that our computers are ready to make the impossible possible, especially with regards to AI at the edge. Sachin, can you tell us a little bit about ZEDEDA?
Yes, absolutely. ZEDEDA provides infrastructure orchestration services for deploying and managed workloads at the edge. So this could be the far edge, close to the well sites, close to the where the actual oil rigs are happening in the energy sector. It could be, close to the manufacturing plant within the plant. And so our specialization is really around the fact that it's a managed operating system, managed orchestration of the workload, as well as now managed AI.
Exciting stuff. So I'm excited for today's webinar, where we will explore a topic that comes up quite often in conversations at the edge. But first, I'd like to ask all of you a question. You'll see a poll pop up on your screen now, and if you could all take a brief moment to select your answer. And here we go. So where are you currently in your AI journey? And we'll go ahead and get the slides ready to come up as well. So as we thought, a lot of you are already moving towards enabling AI, and this looks like the webinar is right timely for this. So let's talk through what our agenda looks like. From where OnLogic sits, the edge isn't just a buzzword. It's a rugged, dusty, often unforgiving reality. Today, we're going to step away from the theoretical and talk about what we've seen right now from the front lines of edge deployments. We'll take you through the edge AI journey, discuss some of the barriers to success, and Sachin will walk you through how to get started and then end with Q&A. One of the biggest trends we are seeing, and extremely relevant to this conversation, is the POC to production chasm. The biggest trend we see isn't a new chip, it's a shift in mindset. That conversation has shifted from how fast can this run to what is the total cost of ownership over 5 years. This is a fantastic starting point to highlight the value of what ZEDEDA and OnLogic have made possible for our customers. Sachin, I'm hoping you can take us through some recent examples that ZEDEDA has accomplished.
Yes, absolutely, Amber. So let's start with some of our customers and the use cases behind them. First and foremost, we want to make sure that there's a value that's hidden today, when it comes to edge AI, and we want to unlock that value. Some of the customers that I'm showing here, let's go through some of the examples. So first, take SLB, right? The idea here is that, as you get next to the well site with oil production is happening, or there's an oil rig, there are a couple of use cases for AI. There's a vision use case for worker safety. There, where if you're entering a red zone, for example, or if you're not wearing certain, PPE or hard hat, certain sort of safety equipment, then you get alerts. Now, the faster the alert happens, the better, operational capabilities that occur behind it. Now, similarly, for example, take Maersk or take Volkswagen. The Again, the example is uh, within a dealership, as a car rolls in for service, there is an application that's sitting and monitoring and looking at the maintenance of the car. And so in that scenario, if you can do better predictive maintenance on based on the mileage, based on certain features that are used here, and alert the right crew for the right capabilities up front to check. It makes a lot of difference. So a lot of these use cases and a lot of these vary across many different verticals, and we want to make sure that we put the value where the business outcomes matter the most. And not only that, it's the same platform. So how do you rapidly realize that across all of these deployments? How do you ensure that the right level of alertness, the right level of timeliness, and on top of that, the decisions uh, are tied to the right business outcome. So another good example would be take Maersk, which is doing these in over 600 vessels, and each vessel has many containers. Each of these containers happens to have these temperature sensitive, information depending on which container holds what. And now all of this data gets accumulated, collected within these servers. And then at that time, if you're running these applications to alert either the fact that, a temperature sensor is broken or something happened, that's one use case. But now map it back into uh, can you update that? Can you update maybe, the app needs to be updated because something's changed. The infrastructure's changed. Maybe the connectivity is also being impacted. So you're moving from a lightly connected zone to a fully dark connected zone, and there's no connectivity at all. So in those scenarios, the actions that take place continue to happen, and there should be really no operational impact throughout this process. So all of this gets deployed over the same platform for from a ZEDEDA point of view, and we help enable manage this. Let's talk about the scale of the problem. So first and foremost, the um, notion is that there's still a wide um, challenge when it comes to adopting AI at the edge. Now, what we are showing you is a couple of these items. So first and foremost, most orgs are spread too thin. They're underinvesting in some of the operational side of it. Some orgs, what happens is they're investing in resources and people and processes, but not in the technology side. And so the variety of struggle varies. So sometimes the POC, the proof of concept, and a lot of the companies struggle on that side. So they're in very early stages. And then in some cases, with the Gen AI, with large language models being at the forefront, people are struggling to figure out the real impact to the business. Now, the value from proof of concept and converting that to production, there's a lot of steps there. And one of the things we can do is first talk about what these steps are. The journey involves, what we call into four phases. So the early stage, or where the most friction happens, is where the pilots are never, they don't just take off the ground. And there could be many reasons. We'll talk about some of these. But as you move through this, you've understood the proof of value, the proof of concept. You've kind of convinced the executive sponsorship around it. And you've also identified the results. The next, right, is around the operational barriers themselves. So you're now moving out of the lab and into the field. That itself is a journey. So, now you have to involve the larger organization. There's a dependency on who you have to work with. Sometimes it's the MLOps team, sometimes it's the OT plus the IT team getting together, and then behind that, as you sort of continue on the journey, you'll find that okay, it's all right to deploy once or twice within the field, but how do you scale? How do you get into thousands of nodes? How do you make sure that when you're deploying an AI model that is versioned and deployed on 10 nodes, and the version needs to not be updated, do you go back and update the same 10 nodes first, or do you roll out the next version first and test it out and then come back and upgrade the versions that are already in the field? So there is a concept for operational rollout, operational maintenance that comes into play when it comes to scaling this out. So once you get into that enterprise-wide deployment scenario, the last and the most important aspect then starts to click in, which is what do you do once all of these AI, applications are out there. Well, what actions are you going to be taking? What agentic operations can you allow? What level of autonomy will you put into place for these agents to be operating on your behalf? So this journey is important for all of us to recognize and stand behind. Let's get into some of the reasons why and where some of these journeys, some of the challenges, some of the hurdles along this journey. So first and foremost, getting off the ground. So there is a unclear ROI most of the time. Um, some reasons are, for example, uh, maturity of the organization. So if it's a where you cannot identify good use cases, where you have unrealistic expectations out of the AI. For example, everybody's gung ho about the technology, but you really don't understand what the end goal is. And that can cause sort of a gap in the understanding from an executive point of view and the outcome they expect to what's on the ground. The second thing is high maturity organizations. They have processes in place. They have, a lot of sort of well-established practice. However, they don't have the right talent. Maybe, they need to outsource some of that. Maybe they need to go outside and find that talent, and that takes time. So now you've got this skill set gap, and you have to build that literacy into your organization. So these challenges, start to sort of manifest fairly quickly. And on both these sides, whether it's a low maturity organization or a high maturity organization, you'll start to sort of lose momentum if you sort of get stuck in these conversations. Um, and what we are seeing is from some of these surveys is that if you're spending roughly, in 2024, people spend roughly $2 million on an organization on Gen AI. Now, the outcome was only 30% of the leadership was satisfied with the what the actual result was. So there's still a gap between the rest of the organization and the understanding of the goals. So how do we close that gap? The second thing is, the notion of adoption itself. So once you've trained everybody, you've understand the skill set, you've sort of taken it forward, you still have the overall data problems. You start to understand that there's a lack of data cleaning, data pipeline. There's a lack of trust. Do you even trust the output? So you have to go back and validate that. So again, it all builds back into creating this ROI for the business and building all of this understanding around it.
Sachin, do you
Uh,
have an example of a time when you've seen the challenge of proving positive ROI and how ZEDEDA might have helped a customer get there?
yes. So first and foremost, the you know there's a conversation that we get into very quickly is do it yourself or buy versus build, right? So
Mm-hmm.
the idea is that you if the customer has not gone through a journey of doing it themselves, of building something and running into the pain points, then they would likely not understand the level of overall total cost of ownership in terms of ROI, in terms of the internal rate of return. So they will automatically not be able to articulate where what the criteria is and where they need to be. So we expect the customer to have gone through some of that on their own and realize the pain points are pretty obvious and clear to them, and they're willing to now take the next step of saying, "Well, I'm willing to get help," and that's where we've seen the results. So we've, for example, achieved over 200% ROI for some of our customers, where it's just as simple as getting off the ground and deploying a node in the lab fairly quickly, and then taking that and moving that to production just on a single node and taking the value, ensuring that it is doable, and this helps one data scientist in the field out there. Now, we need to continue sort of monitoring that and see how it scales better.
Thank you.
Yeah. The other thing we are doing, sorry, is as another point is one of the things we are helping with is we're starting to produce benchmarks. So, these are real hardware benchmarks. So it's not just in a hypothetical situation in the lab where you're training the data or you're training the model on a different hardware, but when you're deploying it on something that's a more low cost solution, maybe from NVIDIA, maybe from Intel, maybe from Qualcomm, And these are not the same pieces of hardware that you trained your model on. Now, in those scenarios, you need to bring that KPI forward. You need to understand the latency. And so if you have that access to that information faster, that helps a
Mhm.
lot. Yeah. Great. Another example. So, this conversation between IT versus OT, the silos continue to exist. We are, although the data shows that now only, roughly 22% of companies are saying, there's a silo problem. There's things are sort of different in terms of the processes and the workflows between these silos. There is always a struggle that we are seeing in terms of bridging that gap. So mid-sized organizations feel that pain points are still there. 41%, of the companies with roughly 250 employees versus 25% of companies under 10. So there's a lot of difference between this notion of integration with the IT practice to the OT side. And then, some of the other angles here is that you really need to figure out at the end of the day, this is a deployment from an OT point of view. So you have to bring the knowledge of the OT and the pain points from the OT point of view and sort of try to bridge that gap between the IT understanding. And a lot of that relates to automation, a lot of that relates to integration. So, and not a lot of the organizations, especially vendors out there, bring that knowledge forward. So how do you bridge that gap fully? So this again causes some sort of a drift between what the IT team wants to do in terms of deploying models and what the OT team wants to do in terms of deploying AI at the edge. Um, let's take another case. So here we have these data points where we are seeing roughly 21% of organizations also cite this example of a hardware mismatch. Maybe it's not the right environment. So there's a lot of decision making in the process where you're identifying some low cost hardware, some based on your form factor, based on the use case, and it takes a lot of iteration to go through that process of understanding which hardware makes sense to deploy and when. So Amber, from an OnLogic point of view, what are you guys seeing there in terms of how you help people build this success from day one, right? How do you help provide that understanding of the mismatch or the for the edge use case, it might be something different.
Yeah, gosh, Sachin, we see it every day where people are building this brilliant POC in a lab environment,
Mhm.
but that lab, that environment, it's destined to field and die in the field. And if you think about it, the lab is a safe 70-degree office. The pilot runs on a liquid cooled workstation that's pulling 300 watts through a massive GPU. But when our customers are moving from that one pilot built in that lab environment to a 1,000-unit rollout, you hit two massive walls. That first wall is the financial wall. If your success requires a $4,000 GPU, but the ROI you're held to is for a $2,000 device, your solution is literally too expensive to live. And then there's that physical wall. The edge is hostile, it's dusty, vibrating, and thermally suffocating. That high-end GPU that you used in the lab with those big giant fans, it will fail in a sealed enclosure under the midday sun, and it will choke on a dusty factory floor. We tell our customers all the time, you can optimize your models all day long, but if your hardware can't survive that ambient reality of the field, you are stuck in POC purgatory. So a working model with nowhere to go. To escape, stop designing for maximum performance in the lab and start designing for the field reality of your day one deployment. That's kind of the message that we like to give our customers.
Excellent. Yeah, I think you made a great point, which is that, it's not just about picking the right model. You have to also align it to the right form factor, the right, sort of uh, physical infrastructure behind it. So
Yeah.
let's understand maybe if you want to shed more light on what that means in more detail.
Yeah, of course. So the model is super important to what you're doing, but the major trend we're seeing at OnLogic is that something we like to term as edge AI overkill. For years, the industry was stuck in this binary. You either had an underpowered micro PC or a massive GPU rig that was melted in a fanless enclosure. I still see where we have customers talking about how they're specing in an i9 and a discrete GPU for a single camera vision workload. That's a recipe for a solution that's too expensive to scale, right? So the secret to escaping that POC purgatory is really identifying if your application calls for the light, medium, or AI. If you're categorizing the workload, it guides you to the right hardware that fits, that's just right. Um, with NPUs now integrated into silicon, like Intel's Core Ultra or the new Qualcomm offerings that have just entered the market, we can move that heavy inference into smaller, more efficient footprints. It's no longer about the raw horsepower, it's about performance per watt. By matching the silicon to the AI tier, you've both solved the thermal reality and the economic reality. But this AI doesn't live in a vacuum. It has to coexist and with the existing infrastructure and those existing workloads. Sachin, how do our customers ensure that these right-sized AI workloads and hardware are actually playing nice in that old world environment of industrial automation?
That's a great segue to the next slide. Actually, let's talk through that. So first and foremost, there is no way out of this. You have to integrate into the current industrial automation infrastructure, the
Yes.
environment, right? Now,
Mm-hmm.
the most important thing here is that to understand that there's a hybrid model, right? You have to bring the Windows VM alongside for the journey as you start deploying containers next to it. So it's not a one or the other. And in order to do that, you have to understand some level of future proofing,
Mm-hmm.
whether, based on your use case, you will be able to deploy everything you need at the edge. Now, where the industry is going is they may start to solve this challenge by looking at the edge as a more of a hierarchy. You get the low-end nodes or devices, as you pointed out in your previous slide, is you can sort of deploy these fan-based or fanless devices at the very far edge, and then you can aggregate some of the additional AI information, AI, the data that gets accumulated, some of the extra processing can occur in a more hierarchical manner in the upfront node that's sitting in a gateway level. So now you get this two-level mode hierarchy that can play a good role. So that's sort of one way of approaching this problem. So you're not
Mm-hmm.
constantly going and updating your edge nodes at the far edge. Now, from a problem statement point of view, right? This is something that our customers have already always told us, which is how do you bring and continue to take this legacy with you? So, for example, some of the survey results are also indicating that you know SCADA systems, right? They will always be living on Windows. They're not going to be changing anytime soon. They may be
Mm-hmm.
getting more advanced in terms of the level of information being processed at the edge, is better and better. But again, it's always going to be a Windows form factor for the foreseeable future. But then on top of that, how do you bring the integration into some of the other third-party tools? So you've got example, a workflow that's also integrating into your cloud. So some of this gets pushed into the cloud, some of this remains on where the edge node is, and then you process it, and then you only push the metadata. One of the surveys we did, the respondents talked about roughly 41%, roughly that number, 40%. They're saying that this is going to be a big problem. How do you bring this integration notion? How do you address it fairly quickly? Because the pattern has to be intuitive, right? So it has to be a model where you continue to upgrade the same legacy applications and the infrastructure next to it, and then maybe cap and grow, or maybe sort of leverage the same brownfield infrastructure for the new AI applications. Now that depends on the size of the model again. Sometimes you have to bring a very small language model versus a large language model. And what we are seeing in the industry is also, for example, there are companies out there, and we'll talk about some of these partners, where they are working on bringing models that are smaller in size, less than 1 billion parameters, and have the same reasoning and thinking that a large model that has 20 billion parameters or 27 billion parameters can also offer. That's a significant milestone and achievement, and I think we'll get there quickly. And the footprint will be less than a gigabyte. So if Then you can start to think about brownfield insertion, keeping that legacy infrastructure intact, but making sure that if you have that OnLogic node already deployed, you can then use the same node to then deploy these small language models as well. Right. Um, so when it comes to model deployment, then the next challenge appears, which is how do you then manage the life cycle of this model? So there is an inherent difficulty because you are taking something that has maybe been trained and developed on a laptop and then moving into an edge node, which houses it as an application. A model has its life cycle, and inherently, then it gets versioned. There are changes to be made. How often do these changes happen? And you also have to understand how the model itself is behaving. From an observability point of view, does it drift? Does it continue to perform the way you had originally intended it to be? Or does, as the data changes over time, does the model need to be updated? Now, there is also another challenge on top of this. The more retraining activity that you have to do at the edge, the more difficult it gets to then deploying more models at the edge. So it's sort of fulfilling, cycle by itself that you have to really focus on model management at its own problem. And once you've sort of had a handle on that, then, deploying more models becomes an easier part. One of the other things we've noticed is that in this scenario, one of our customers has said, "Hey, we'd love to, deploy four vision models. They all do different things. One does, object detection. One does people behavior detection, looks at, people's faces and determines certain things or reactions. One looks at, from a traffic point of view, how many cars are coming in. So they're all vision models, but they're all doing different things." And all of them need retraining because they're all been narrowly fitted, narrowly trained for specific purposes. And suddenly you've got four vision models sitting on this edge node. And now there are two things that are happening. One, you're running out of resources on this node. You cannot fit the next fifth one. Let's say you need another vision model. You can't do that. Second thing is you need to retrain one of these all the time. One out of four. That's a 25% rotation happening all the time. Something's giving, maybe you haven't done a good job of, upfront training or too much narrow data windows being trained. So figuring that out makes it super difficult. So one of the approaches now that we are discussing and talking is how do you bring a hybrid approach even there, where you bring a more reasonable approach to saying, here's one narrow model, does its job, but now you've add a reasoning and a thinking model next to it. And that does the heavy lifting of anything that's missing from this model that's been trained. That's just one approach, right? The other issue here is that also there's a governance issue, which is even though you have determined certain models to be deployed at the edge, how do you make sure there's guardrails? How do you make sure, the OT team is okay with some of these models being deployed? Maybe they would like to, make sure that let's do this in a certain rollout fashion, but also be able to say no, and in a very easy way, right? So not just, send an email, but actually be part of that workflow that helps with the governance. So those things start to matter as well, and they obviously pose a challenge today. As we continue, right, the other thing is the infrastructure itself. See, the complexity is starting to show up when you start to scale. So when you have a diverse set of edge environments, highly distributed, it is extremely challenging to say, I will deploy this across this footprint, which is based on, say, Dell, another set of footprints, which is based on HPE, another footprints based on, another vendor, Lenovo, so on and so forth. They all, while they all have to be managed in the same way, um, there is some nuance in terms of how you deploy this in a heterogeneous environment. It's not maybe also just the vendor difference, it's also the size, the resource availability, whether it's already constrained, whether you need to go and deploy something or you have to wait. So now you have this challenge where organizational size or the size of the install actually starts to play a role. So now for us, we've been sort of looking at this problem for over a decade in terms of production edge deployment, tens of thousands of nodes, and understand the capability up front as we do this. With advance in Kubernetes, with advancements in AI, we are starting to build those further and enhance those. Um, so one other thing to note here is that the complexity and the obstacle is really depend on, again, how quickly you get out of the lab. But once you're out in the field, the operational challenges start to change in terms of what workflow you've set up. Do you bring that hardware back into the lab, resurface it with new models, and push it back via a truck roll? Or are you willing to take chances to say, I will not do a truck roll. I will actually stop the truck roll and I'll move forward with with doing this over the air and have the confidence to do that. So there has to be some trust, there has to be some governance built into whatever solution that's out there. And that is very hard to do today.
So thinking about the three pilot sites and then going out to 300 sites, it's an explosion, right? But beyond the models themselves, how does ZEDEDA automate the provisioning and orchestration of the fleet that's truly distributed at scale?
So today what we do is we're leveraging different technologies. We take the page out of Kubernetes and we've built uh, the same automation that IT teams are using to then leverage the same across the OT side. So GitOps, for example, is a great practice where your IT team pushes a change in the model or the application in a declarative fashion, and that change can then be pushed further out as a deployment into the fleet. Now, where it becomes interesting is what we're doing is, and what I'll talk about later, is we can start to add the governance. So the OT team gets involved. There's an administration oversight which can then approve that change and whether change needs to be done in a slow rollout or whether it's good enough that it can be done right away. Now, only the OT teams really know what's going on from a OT point of view. What's on the ground, whether they need to wait a couple of days, a couple of weeks, something's changing. Maybe there's an infrastructure change happening that the IT team was not aware of. So this is where, we will bring in that governance, bring in that extra approval, and that will help. The other thing is, ongoing automation. So tools like Terraform, tools, these are super important. They are highly leveraged already. And enhancing these further, we are, leveraging the same sort of API first set of tools will help. And lastly, as with AI, we are happy to bring sort of newer concepts like MCP and other areas where now there is a model context protocol, MCP, which enables this integration in a much easier manner. And then there's an agent to agent communication that's going on. All right. So let's talk about the last piece, which is probably, something that, as part of the journey you have to address at some point, which is how do you then take an action? So you've been in the exploration phase, you've got these agents that are deployed, they're doing certain tasks, they're purpose-built tasks. But how do you connect these agents and the output of these agents to certain actions? That becomes a super interesting challenge. You know, um, so once you're out of the research mode and how do you move from a simple processing of these outputs to a more agentic automation where action is happening? Today, for example, the companies that we're talking to, they say that they're still in the pilot phase. They haven't really deployed an agent that can actually take an action. They're not sure. There's a concept that we are dealing with right now in the industry. It's called autonomous versus autonomy. Autonomous agents have full autonomy in terms of they have full approval from the human to say, go take a task, go take an action, and finish the action. The level of autonomy today, based on the level of trust you give to the agent, and that is not in place today. You have heard of the term human in the loop. And the idea is that in order to get to 100% autonomy, you have to bring the human in the loop first and edge your way into giving the full autonomy to the agent. So this concept is new. Today, everybody starts with human in the loop for most tasks, for most approvals. And then over time, they sort of gain confidence. So roughly 40% of the data shows that you could give the agent full, 40% autonomy to make some decisions. But behind that, you have to then bring the human in the loop again. So we will see a progression here as well. So once you start talking about the action, you have to talk about autonomy and how autonomous you want your agent to be. And then that conversation starts to become interesting. And tracking it becomes interesting. How autonomy over time progresses for certain agents. It's ridiculous. So yeah. Um, Great. So let's conclude on this section, which is we talked about several challenges. We talked about, the fact that um, AI requires proper planning. So if you see some of the latest tools out there, now they have a plan mode, and this is highly encouraged because you can change the plan, you can tweak the plan, but until you have a plan in place, you cannot move forward with the implementation. So similarly, as these AI tools are bringing this planning phase forward, there's a business planning part of this as well that has to happen. There's an outcomes that has to be aligned with the executive team, and that has the most important impact to the project taking off thing around the integration, right? Making sure that it's not a cap and grow. It's a insert into the existing workflow. Bring the same legacy workloads, and they're not legacy, they're actually current, but they happen to be on different form factors. And they happen doing certain things until they are fully refactored, until they're fully, uh, you know, um, deprecated. You have to maintain these over the next several years. And then scaling, right? Scaling is a challenge because scaling can happen in many different ways. And how you orchestrate, how you drive this across the fleet will impact how you end up adopting AI. And lastly, this notion of having an action and really taking something more at the edge and giving more control to the agents over time. So, just a quick recap then. We talked about these four-stage journey of the AI at the edge and ensuring that you've got to get off the ground and get through the early friction, get through the operational barriers, talk about scale, and finally consider what you can really do with this and unlock the value there. So with that, I will jump into how we get started with this with ZEDEDA. So first and foremost, I want to talk about our edge intelligence platform. We launched this couple of weeks ago. And the idea here is that we help you create, secure, and operate edge AI at a very different scale. So the goal is not to just do lab exercises, get into a pilot, but get the pilot off the ground as quickly as possible and deploy it at with ease at scale. So how do we do that? Let's jump into the details. So first and foremost, we have the infrastructure layer, which has the hardware. There's GPUs, NPUs, TPUs. There's a lot of new entrants coming into this space. We are dealing with, for example, PCI-based, accelerators, which are now also TPUs. We are also looking at discrete GPUs as well as integrated GPUs. So your new SoC-based GPUs, which are also NPUs. So a lot of different dependencies from a library point of view, from a hardware acceleration point of view, from the right form factor then gets enveloped around it to then what inference model do you actually need to pick and drive. And then finally, the agents on top. So today it's a business logic application that's hard coded. It treats the input and the output from an AI model in a very discrete fashion. That's what today's AI application looks like. But tomorrow it could be an agent that's more fluid, that's given a smaller task, and then hands off the output of one task to another agent, and then another agent and another agent until the task is complete. So having sub-agents run on a physical edge node and then all of them running to completion to a certain task starts to become the norm over time. We're not there yet, but that's the direction we're heading in. So in order to do that, you have to expand that ecosystem. So on the right side, from a traditional application vendor ecosystem where applications are being built from a verticalization of the full stack point of view, there is now an ecosystem that's opening up with just the models, where you can bring just the models from a third-party registry like Hugging Face or NVIDIA NGC catalog, or from your own S3 bucket, you have maybe have a custom model, or from Qualcomm's AI Hub. So these start to play a role because the model is decoupled from the business logic. And so the model plays a role. The model file is mostly open sourced nowadays. It may or may not be commoditized. For example, vision models today, they're highly commoditized. The standard machine learning YOLO model is available to everybody, and as this increments in its version and its evolution, it's everybody starts to leverage it as is. There is very little change to be made. It's how you feed the data, how you train the model that becomes super interesting, which means the iteration on vision is going to be highly likely. So a much more higher iteration. Your vision models will change significantly at the edge. Now, in order to keep up with that iteration, with that rapid turnaround, as you add more vision and more speech to text or text to speech model capabilities, your speech goes and gets translated to something that can then be acted upon. All of these capabilities combining together means that you're constantly iterating on the models, not the data, but the models. So in order to do that, you have to bring a platform that can do rapid model lifecycle. Um, so how do we do that? In a little bit more detail, we have our favorite OnLogic hardware here. And as we sort of take that and deploy it, first and foremost, we have our Eve operating system that runs on it and it's installed. Once that happens, it automatically reaches out to the cloud and connects via a secure channel. Once that's established, we launch the infrastructure that's needed for deploying the applications, deploying the models themselves, deploying the agents, and that's the Kubernetes infrastructure. Everything is tying into a Kubernetes environment. Kubernetes is the now widest, most widely adopted ecosystem out there when it comes to AI, and we want to ride that with the Kubernetes infrastructure. Once we select the model, we actually auto-select the dependencies. So the inference engine. So for example, if it's a machine learning model, um, or let me talk about YOLO, and you're driving on a CPU, OpenVINO is the most standardized inference engine that you can leverage. If it's maybe a CNN model, like convolutional neural net, or if it's a Gen AI LLM model, large language model, for example, like Nemotron, then you need to tie it down to the right inference engine, which is a VLLM. So we will do that automatic selection, automatic curation of the inference engines behind it. We'll work with the chip manufacturers to make sure we've taken the latest and the greatest changes and continue to iterate on that so that the our customers focus is always on the model iteration, model development, model training, and model deployment rather than all the dependencies behind it. So once that's done, then we take that application itself. Today, that application is a hard-coded business logic application. Tomorrow, it'll be an agent that's actually mapping back into the right model, and that maps back into the right hardware and the right NPU or the CPU or the GPU. So great. So this is how we end up doing all of this. And just to walk you guys through some of the tangible screens that we are doing. So first and foremost, we have this model catalog, which is part of a model hub. We bring a lot of models from different sources. So we can bring models from Hugging Face, for example. You can download the latest and greatest models. You can see the additional sources, for example. We support a growing ecosystem out there. Um, Azure, Hugging Face, your own MLflow uh, environment, maybe an S3 bucket, it's a custom model, NVIDIA's NGC catalog. All of these start to sort of may play a role. Amazon. So we are conscious that we are not the source of all these models. These models are evolving really rapidly, and our job is to make sure we can house these and curate these on behalf of our customer in a central way, and then hook into their centralized repositories as needed. Once that's done and you've imported a model in this example, you can see all the related metrics. So where this model was deployed, when it was originally brought, what version it was brought into. We also have this notion of a staging workflows of these models. So models go from development all the way to deployment stage. And that's important because that is missing today. You have to be able to identify the fact that some models might have been trained in the centralized cloud, but they still are in a development stage when it comes to edge deployment because there's still some testing, there's still some validation. And until that happens, you don't want to move into production. So the other thing we're doing is, I talked a little bit about this, is we are helping bring additional information around benchmarks upfront. And we're working, with partners like OnLogic to make sure that that benchmark happens on the right hardware. This helps with two modes. One, the hardware selection, the right form factor, the mismatch problem that we talked about. We try to address that by saying, here's what you can expect in terms of the latency of the model once it's deployed, not the accuracy. The accuracy is already done. That's not the purpose of this benchmark. This benchmark is to enable the fact that you can expect certain latency metrics, as well as certain throughput, certain power, certain, CPU, everything that's related to the latency of the model, the performance of the model at the edge in terms of tokens per second. Once you determine that, you can expect this is how it'll behave once it's actually deployed. You might have a surprise upfront. You might realize that the model wasn't fully optimized. You might realize the model quantization did not happen appropriately. Maybe that needs to happen. So this level of experimentation can be done upfront in the lab environment, even way before, much early in the cycle than when you move into production. This is super important. Like I said, this helps determine not just the right hardware, it also helps determine the right model. Maybe this was not the right model. Maybe it should have been a smaller model. Maybe it should have been a simple machine learning model to start with, versus a larger model with more parameters. So this level of approach really helps quantify that further, and then this helps take that project off the ground because now you've sort of made this determination upfront. Once it's deployed or once you're ready to deploy this, we'll go through this notion of a deployment pipeline as well. And this is where we're bringing in this governance, where we're saying it's great that someone did the work in the lab. Now you have to get the um, person out there. Maybe it's an OT admin, maybe it's somebody else. Maybe it's an ML ops that's tied to the OT admin team. Someone who else is having an oversight to approve the overall workflow and the overall deployment. So it's one more check in place to ensure that this model does not just get deployed right away. And that's the challenge with today's current GitOps flows. Once you hit that button, it goes all the way through until it's deployed. And what we've done is we've built in this extra oversight, this extra approval in the workflow from anybody you need to be able to do that and to be able to stop the workflow midway. So, and then here's an example. So this example is actually an agent deployed on an edge node. And what it's showing is, in this case, this is a PCB quality agent. So its job, it was trained. It's actually an LLM agent. It's based on an LLM, and it's a thinking model, a thinking and reasoning model, which means you can actually interact with it. And it is deployed as an agent, and it's been given a task. Its task is to determine the quality and inspect the quality from different angles, from different areas of images that are received from a camera that's looking at a PCB device that's running on a conveyor belt. So within a manufacturing setting, you can really now understand the level of advantage here, where you're not just deploying a narrow, classically trained machine learning model, but you're actually deploying an agent which has thinking, reasoning, chain of thought all built into it. It can do more than just detect an object. It can tell you more information about what it's seeing, and then you can fine tune its expectations based on either single shot prompting or even fine tuning based on the data you may have collected in the past. All of this is happening at the edge on that node as it's doing this. So the data processing, the information. Now imagine tying this action to an actual alert or an actual notification behind the scenes where the quality inspection suddenly doesn't pass, the criteria. that becomes super interesting. Another example of another agent is this kiosk agent. Now you have this agent which is local, sitting right next to the kiosk. And so today, this agent can independently, autonomously detect what you're doing with your in the retail space and what you're purchasing. You can pick up any of these items, it'll tell you right away, and then it'll give you the bill. It does not have to be centralized. It does not have to be centrally controlled. It does not have to be centrally managed. It can independently determine all this. And this is where one of those examples of autonomy comes into picture. If the task is about understanding uh, what quantity and what build to generate, that's a super autonomous task that you can give to your agent and go. So this is, where the human in the loop does not have to be in the loop. So, and a great example, in using a thinking and reasoning model at the edge. And yeah, with that, I think I want to pause and say, yeah, that's what we need to do. We need to start thinking about getting out of the pilot phase and getting to production.
That's awesome. Thank you so much, Sachin. Before we get started with any Q&As, and reminder to the audience, if you have questions, please go ahead and put them into our Q&A. We do want to ask you guys one more poll question. So I'm going to go ahead and launch that now. While our audience is responding, Sachin, if you had to give someone advice about getting started with their first Edge AI pilot, what is that number one thing you would tell them to think about before they got started to ensure that they're successful when they go to scale?
Excellent. So there is a notion of prototyping that is emerging as part of this practice. So, do some prototyping, get some experience, get some learning in the picture, and then build a plan around the learning. So that's super important. Uh, I think it's helping us in just in every facet, not just in deploying from pilot to production, but just in building more product. So do more prototyping, get a better understanding and learning, and then obviously always be able to fail fast. So and that has to happen in your prototype phase. It should not happen in your production phase.
Failing fast is so important to anything that we do. So thank you again, Sachin. This was fantastic. And thank you to our audience for listening. We're going to go ahead and wrap up some Q&A. And we did ask for a couple of questions in advance, so we'll start with those. And then we will touch on any live questions as they come in. So the first question that was submitted was the abstract mentions intermittent connectivity. If a site goes offline for 48 hours, what happens to the AI inference and the management orchestration? Does the edge node become a black box, or is there a way to ensure autonomous operation and eventual data resync? I think this one's for you, Sachin.
Right. Yeah. There are two things that you can do from sending a truck. One is, you have to prevent it. So, which is you have to bring this notion of governance that we talked about, have version control in place, have approval workflows in place. All of this helps with preventing something going wrong. So that's the first piece. Where because once you're deploying these edge nodes, you have to remember that you can recover these remotely. With ZEDEDA, we what we do is we by default have design security in mind. So we are locking these nodes. They're tamper-free, tamper-proof. You cannot SSH into these devices unless it's explicitly turned on. Every node you can trigger in an automated remediation way remotely because you don't want to send a truck out there in the field. So those things you can recover immediately, but you have to remember that the way we are building the security into the picture and into every node that's being deployed, we have built a layer of trust. And if the layer of trust is broken, we'll have the box be shut down. But outside of that, if there's disconnected states, if something goes wrong, we understand that, and the box continues to operate. And once they're back online, we can continue to sort of manage them.
Awesome. All right, so question number 2 was, a lot of our AI models require high-end GPUs that generate significant heat. In a non-climate controlled factory or retail closet, how do you balance the need for high compute performance with the reality of fanless, dust-proof hardware requirements? That is a really good question. I'll take this one if you don't mind, Sachin. OnLogic solves the heat versus dust dilemma by moving away from off-the-shelf cooling and toward environment-specific engineering. So I want to give some examples. Within our rugged line, our Carbon 525 utilizes MXM GPUs in an ingress isolated architecture that completely separates the air blowing through the system from the sensitive electronics inside. MXM GPUs are more heat tolerant and perform better at higher ambient temperatures versus the most standard discrete GPUs. Another one I would highlight is our Axial 300. This is a product that's part of OnLogic's Edge server line. So this can support multiple GPUs and also features MERV4 filtration and closed loop temperature and airflow monitoring to ensure the systems are running optimally unless in optimal environments. I guess I'd also highlight that by supporting less power-hungry architectures with accelerators like Halo or Intel Core Ultra CPUs that have integrated NPU and high-performance integrated GPUs, allow for that AI inference with less energy consumption, and therefore it reduces those thermal requirements. I want to give a shout out to ZEDEDA because part of your new Edge Insights platform that I really love is that you guys give a window into the hardware that's providing that real-time data on exactly how your GPU is performing. So our customers can gain that peace of mind that comes with knowing your AI is running cool and efficient regardless of where it's deployed. So that was a great question. Thank you. All right, so we have one more. This one looks like it's for both of us. So digital transformation teams often struggle with the handoff between the data scientists who build the models and the OT teams who maintain the factory floor. How does ZEDEDA and OnLogic simplify that handoff so that an OT tech can swap a unit without needing to know Kubernetes or Python? Boy,
Right.
Sacha, you want to take that one first?
Yeah, I can get started and then I'll hand it over to you. So,
Sure.
this is where security actually at the edge fundamentally sort of diverges from the security in the data center. We have to prove that the device is hostile, and so that means that it's zero trust, and with that in mind, right, we create this layered trust approach. So there's hardware root of trust, there's measured boot, and there's attestation at every layer. Once that's established, right, we also then lock down the node, the no local login, no SSH, and we have this mutual TLS, connection that's established, and so the communication only happens over this secure channel. So if there's a physical compromise on a node, they can't move this across the network. It'll get locked down. Now, with OnLogic hardware, I think it really complements the fact that the enclosure is physically hardened, and the support for TPM exists across the entire product line. So I think overall, you get a tamper-free device, right? Which is about, which can be easily detected and quarantined. So I think that really helps us from a software stack point of view, build that logic around the OnLogic hardware. So over to you, Amber, if you want to add.
Yeah, that was, I think I might take a slightly different approach. So when I'm kind of thinking about the handoff between the data scientist and the OT, I think it usually comes down to that environment drift, which, back to that prototype in the lab and then the field reality. So the reality in the field is that there's different OS patch or different drivers and then everything breaks. But, we as OnLogic, we're trying to solve that for our customers for that data scientist to OT handoff by making sure the hardware is validated and the foundation is there before it even leaves our manufacturing doors. So at the silicon level, when we work with a data scientist, we want to make sure that we're validating the exact that light, medium, or heavy profile that they need, and then lock that hardware bomb down, ensuring that those instruction sets and the NPU performance are identical across that prototype unit all the way to those thousands at scale. The other piece I think that we do really well is that factory imaging. So we can take a custom image from the data scientist, their golden image, make sure the OS, the drivers, the container runtime, and flash it onto our hardware during our assembly process so that when that OT admin opens the box and gets it ready to go, it isn't just that blank slate PC. It's pre-configured and ready to go. It just needs to connect to the network. And then last, I guess, it's that physical to digital parity. So OnLogic works really hard to ensure that those physical IOs, those sensors and cameras, that's what the O team really cares about, that it's mapped directly back to that virtual environment that the data scientist built. So, ultimately, by the time the box reaches the factory, that computer science is already solved, and the OT team gets a reliable industrial piece of hardware, and the data science team gets a predictable high-performance canvas that doesn't change. So it
Right.
looks like we're about out of time. I want to thank everyone for attending today, and especially thanks Sachin for joining me on this webinar. It was a lot of fun. A reminder to everybody, please check out OnLogic at onlogic.com and ZEDEDA at ZEDEDA.com. And think of us whenever you're getting ready to kick off your next Edge AI pilot. Take care.
Take care.